Okay, in this video, we're going to look at 12-2 from our geometry book. It's called Conditional Probability. Now, you probably have not talked about conditional probability before, so it can be a little tricky. So we're going to look at a couple of examples today and make a couple more videos on this to help you try to figure this out. I would suggest reading the book and finding some examples online and watch the videos over and over again until you get it. But once you get the hang of it, it's not that bad. All right, let's look at the definition of conditional probability. Here's the definition. The probability that an event B will occur given another event A has already occurred. This is called conditional probability. So you're looking for the probability that an event B will occur given something else already happened. Okay, that's called condition. The condition is something else already happened. Okay, the notation is at the top here. It's probability of B with a line, a vertical line, A. And you say that notation this way: the probability of B given A. So the little line means given. Okay, let's look at an example here. So here's a table that we have, and the easiest way to see these conditional probabilities is through tables. So on your quizzes and tests, I'll make sure I have these tables set up for you. Let's just understand what this table means right now. The row 1 here, SP is sophomores. So this row 1 is sophomores. Row 2 is J for juniors, and row 3 is seniors. On the top, we have our different clubs. We have our drama club, science club, and art club. And in the green boxes, it's just our totals. So the total is read from across the row. So we look at the first row. The sophomores in drama were 3. Sophomores in science was 9. Sophomores in art was 24. And the total sophomores was 36. If we look at the bottom right corner, that is the total number of people that are in this array here. So 115 people that we have. Okay, so let's look at a question. We're going to come back to this box a lot. So the question is, what is the probability of a junior given they're a member of art club? So when we look at the table, all we have to do is look at the number of juniors in the art club, okay, which is this cross section right here. So the probability that they are a junior given they're in an art club. So this is this box here. I'll color it blue. Okay. That's just what we want here. The cross section of my column of art, my cross section of junior. So that's going to be 16. Okay. Now, what we need, that's what we have for our numerator. So junior, given that they're an art club, is our top. So this is the number of juniors in art club. That's the top. Now in red, we need to figure out what our denominator is. Okay. So, and we only care about the juniors in this case. Actually, sorry, the number of art club members in this case. Okay, so the number of art club members are going to be 58. So look at the column here. Okay, so this is our box that we only care about, given that they're an art club. Okay, so art club is 58 members. Let's go back to the question. Junior, given they're a member of the art club. So all we care about the juniors in the art club. Okay, so it's going to be 58, and that 58 is the art club members. All art club members, which includes sophomores, juniors, and seniors. Okay, so that's our probability, and we could just simplify that down to 8 over 29. And that's our answer. Okay, so we could also have solved this problem a different way. by using this formula here. So this is the formula for conditional probability. Okay, and it looks a little crazy, but it's not too bad. So probability of B given A is equal to the probability of B and A, okay, over the probability of A. Okay, so if you notice here, it's a little pattern you can see. The probability of A is on the bottom and the given A is on the bottom as well. And the top is a combination of those two, B and A. Okay, now probability of A can't be 0. Okay, if probability of A is 0, you'll have a 0 in the denominator and you don't want that. Okay, so if we go back to the same example here, we want to find the probability of a junior given that they're in the art club. I'm just going to abbreviate it. Just put art right there. Okay. And so we're going to do the top of the numerator is the probability of a junior and art over the probability of art. Okay, let's use a different fraction here, different color. So juniors and art. Now this is the full probability that we're doing, not just a cross section of a number from the table. So we need to do a full probability. So the probability of junior and art. So if you go to junior and art on our table, it's still the 16 right here. But the difference is you're going to do 16 out of the total, because the probability is a desired over total possibilities. The total is 115. Okay, that's the top. Let's change the color for the bottom. Now we're looking at the probability of art in general. Okay, so here's the probability of all of our art on the bottom here. Okay, so that's all of our art students. So we're going to have, it's going to be 58 over 115 as well. Over 115. Okay, and now we're going to get the same answer, okay, because look at the 115s. Those cancel each other. You have two fractions on top of fractions. The denominators cancel if they're the same value, okay? So look, we get 16 over 58, which is just like we got here, 16 over 58, and we just reduced it down to 8 over 29. Okay, in the next video, we're going to look at independent probabilities and how to tell if probabilities are independent based off conditional values.